This is Unit 5, Periodic Table, Lesson 5, Trends in Electronegativity. How can we predict changes in electronegativity using the periodic table? By the end of this lesson, you will be able to describe the trend in electronegativity down a group and across a period, and you'll be able to explain why these trends exist. So do now. So electronegativity is defined as the measure of attraction for electrons, and these values can be found on Table S, the electronegativity values. So for fluorine, the way I always remember it is fluorine is the most electronegativity with a value of 4.0. So the closer an atom is to fluorine, the higher the electronegativity, and it's on a scale from 0 to 4. So this is just a relative scale. The trend in electronegativity increases across a period because there is a greater proton pull or attraction to electrons. So if I have a greater pull on those electrons, it's going to be harder for me to, or I'm going to be more attracted to them. So the electronegativity really has to do with the attraction for electrons in another atom. So for example, using our same elements, 13 plus has less proton pull. So I'm pulling these electrons in less. And the same would go if I had another atom next to it, I would have less pull on those atoms' electrons. However, if I have a greater positive charge, I have the same size atom because I have the same number of shells. So if I have an element nearby, I'll have a greater pull on those electrons. Going down a group, the electronegativity trend decreases because there's a larger atomic radius, which means there's less proton pull to attract those electrons to the valence shell. So using the same visual, if I have a smaller atom, I'll have less space to reach across, so I'll have a greater pull on anything at the edges or near me. If I have a large atom, I have a greater distance to pull through. So those electrons on the outside, I have less pull on, and anything next to me, I have less pull on. So what is the trend in electronegativity across a period? So as I go across a period, my electronegativity increases. Why does this occur? Because I have a greater proton pull. Greater proton pull. Or nuclear pull. And we can remember PPP going across a period, greater proton pull. So the trend is increasing, and we can also just use the electronegativity values from table S. So in period 3, sodium has a 0.9 electronegativity. In period 3, chlorine has a 3.2 electronegativity. So going from left to right, my trend in electronegativity is increasing. So check your understanding. And you are now able to describe the trend in electronegativity across a period and down a group and explain why these trends exist. So I also like to have this quick summary table. The way I remember it is what we call Mary. Metallic character is going to, it decreases going across a period and increases going down a group. So if I put those together, it's going to increase in this way. Electronegativity is the opposite. It increases going across a period and it decreases going down a group. So if I do the diagonal, it's going to increase up towards fluorine. Atomic radius is similar to metallic character. So it's going to decrease going down and increase going, you see what I'm doing. And the variation for ionization energy is the same as electronegativity. So if you remember Mary, it's down to the left, up to the right, down to the left, up to the right.